Hello everyone, welcome back. This is Engineer Hussein Mosapi. Alright, so in this video, we'll be looking at how to find the dimensions of a rectangle whose perimeter is given and whose area is a maximum. Alright, so this is a condition that is under the applications of differentiation. Alright, so before we begin, do not forget to like and subscribe to the channel. All right, let's get to it. So I'll basically explain this with an example. So the example says that find the dimensions, which is the length and width of a rectangle whose perimeter is 40 inches and whose area is a maximum. All right, so let's first visualize this. It's a rectangle. So I bet everybody can draw a rectangle. So we know a rectangle has a length and width. Others can use a breadth, but let's use what we've been given. So we have L and W. So we know that it's a rectangle, so this side is equivalent to that side, so this is also L, and this side is also equivalent to this side, so it's also W. Now, with this information, we need to know that every time we've been asked to, say, solve questions under this type of a condition, remember that the key is to use the formulas of the quantities given, then apply the first derivative and find the critical points of the variables. So in our question, we're having two particular quantities, and these are firstly the perimeter and secondly the area. So perimeter is the total distance around the given shape, while the area is just the space occupied by an object in unit squared. So let us use these quantities that we have. So now perimeter P is the total distance around shape. So I'll say L plus W plus L plus W. This will give me the perimeter. If I collect the like terms, I have L plus L plus W plus W. Perimeter is equal to 2L plus 2W. Now, this is what we have as the equation for our perimeter as data 1. As data 2, we'll have the equation for the area. So area will be L times W. So L W. Now, between the two, which one am I going to use first? Now, according to the question, the only quantity which has a value is the perimeter. If the area had the value, I would have used the area first. But now the perimeter is the one having the value, so I'll use the perimeter. So perimeter has been given to be 40 inches. Therefore, perimeter is going to be 40, being equal to 2L plus 2W. Now, this can be reduced. We can either divide throughout by, let me not say either, let's just say we multiply by half so that we can divide throughout by 2. And we'll have 20 being equal to L plus W. Same as 1 having L plus W being equal to what? 20. And this basically will be our equation number 1. Now, this equation number 1 from our evaluation can be plugged in the data equations that we have found. Now, we have used data 1 because the perimeter was what was given. Now I'm going to use the area equation to see what I can get. Now remember that the key is to use the formulas of the quantities given, then apply the first derivative and find the critical points of the variables. Area is equal to L times what? W. Now in what we have from equation 1, we can make either one of the two the substitute formula. If I make L the substitute formula, I will have L being equal to 20 minus W. W goes the other side. And I will have this equation. Now that I have the value of L, I would say area is equal to the value of L, which is 20 minus W times W. Therefore, this is 1 having the same as W times 20 minus W. And this W multiplies each particular entity in the parenthesis, and we have the area being equal to 20W minus W squared. Now, this could be the same even if you had made W the substitute formula. You still get the same values. Now, to create space so that you can easily see what I'm doing, let me just erase the top. Alright, now you need to understand that we have the area being equal to 20W minus W squared. Now we have manipulated these quantities and we have another equation here, which is the one involving area and the perimeter of a particular aspect, where we have used the length as a subject of the formula. Now, once we do that, remember that the area is a maximum. Now, because of that, we need to now find the first derivative. Finding the first derivative, a prime, will be equivalent to 20 minus 2w. After that, we need now to determine the critical point. And the critical point is literally the point where the first derivative is equivalent to 0. Now be mindful that this function is a with respect to w. So a prime is the same as dA over dw. Therefore, I will let a prime equal to 0 so that I can determine my critical points. Therefore, I have 0 being equal to 20 minus 2w. Just erase the bottom quickly. Now that I have that, this can also be written as 20 minus 2w being equivalent to 0. If I solve for w, I have a 20 going the other side, and I have minus 2w being equal to minus 20, because 0 is basically nothing. Solving for w simply means that I would divide both ends by minus 2 because I'm looking for w and not minus the 2w. Therefore, w is equal to, this cancels with that, and 2 into 20, you get the width to be equivalent to 10. Now that we have the width, it is now going to be easy for us to find the length. Remember that the length, L, is equal to 20 minus the width. Therefore, L is equal to 20 minus the value of the width, 10. Therefore, L is equal to 20 minus 10, which would be 10 as well. Now, as you can see, we have determined the value of the dimensions. The length is 10 and the width is as well 10. So any question where they will ask you to calculate the dimensions of a rectangle whose perimeter has been given and whose area is a maximum, remember that the key is to use the formulas with the quantities given and then apply the first derivative and find the critical points of the variables. Remember to manipulate what you have depending with what you have in question, and then substitute where need be in your equations. Alright, thanks for watching. If you have queries, you can always reach me on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress. And don't forget to strategize before you become a statistic. And let's try and push for that A+.